All right, so we're going to go ahead and try and solve this problem. And what we have here is first, we're going to be looking at what is the acceleration in the x direction. We're going to first start by choosing a nice, convenient coordinate system. And we're going to call the right x positive, and we're going to go and call up y positive. What is the acceleration in the x direction? So that means we first have to find the net force. So we're going to first sum the forces in the x direction. And since we're calling x positive that way, that means that we have positive 5 newtons minus 3 newtons, which gives us 2 newtons. So we do have a net force in the x direction. Since we have a net force in the x direction, we're going to go ahead and set that equal to mass times acceleration using the second law. So we're going to sum the forces equal to mass times acceleration. And remember, we're looking at the x direction, so we're going to say acceleration in the x and net force in the x x direction. The net force in the x direction is 2 newtons. And the problem told us that the mass was 2 kilograms. And so we're going to plug that in also. So we know that the mass is 2 kilograms. And lo and behold, what we're missing is the acceleration in the x direction. In order to solve for a, we're going to go ahead and try the opposite. This is multiplying, so I'm going to go ahead and divide both sides by 2 kilograms. What I do to one side, I got to do to the other. This goes bye-bye. And so we find that the acceleration in the x direction is 1. And you can prove to yourself that this will give you units of meters per second squared. And we found the acceleration in the x direction. We're going to do the same thing with y. On the y, we called up positive, and it's only 2 newtons up. So the net force is going to be pretty easy. I'm going to say that some of the forces, there's only one in the y direction, which is 2 newtons. And once again, we do have a net force. That means it's unbalanced, and we do have an acceleration. And we're going to set that equal to ma. And this is going to give us our acceleration in the y direction. So 2 newtons is equal to, the mass is still 2 kilograms. And we don't know the acceleration in the y. So we're going to divide both sides by 2. Pretty much the same thing. It's kind of convenient. What we get here is, this goes bye-bye, and our acceleration in the y is once again 1 meters per second squared. And what we have here is the acceleration in the 1 meter per second in the y and 1 meters per second in the x. And we want to look at that like a vector. So I'm going to go ahead and draw this out. So that has an acceleration of 1 that way, and this one has an acceleration of 1 this way. And remember, we're going to add these vectors. And when you're adding vectors, we want to do tail to tip, right? And what we're going to do is we're going to add these 2 vectors here. So I'm going to put the tail of one on the tip of the other, and I'll just draw that a little bit bigger. So this will be 1 meter per second squared. And then we're going to put this one here on the tail of the other. And what we get is our resultant vector, which is this guy here. And that is kind of what we get, the total acceleration. And we need to know what that is. So we know that this is 1, we know this is 1 meter per second squared. We're looking for this unknown here. And to do that, what we got to do, you should realize that what we have here is kind of like a Pythagorean theorem situation. And so what we're going to be looking for is C. We'll call one A and we'll call one B. And so we set a squared plus b squared is equal to c squared, which are nice numbers, fortunately enough. A is 1. I'm going to leave out the units just so make it a little bit neater. Now you can always prove to yourself that the units work. Is equal to c squared. 1 times 1 is 1. 1 times 1 is 1. So what we get here is c squared is equal to 2. And then we're going to square root both sides. We're going to try the opposite. We want to get rid of that square. We're looking for c. And here what we get now is c is equal to the root of 2. And you can put that, and it should be meters per second squared. And that's what we found. Now it'll give us a decimal if you put that into a a calculator, and that's good. Now the last part you want to look for is this angle. It asks you for the angle and mix with the horizontal. So we're going to be looking for this angle. So I'm going to go ahead and redraw this so that we can see this. See what's going to happen here. We have an acceleration vector like here. that is root 2 meters per second squared. And what we're going to be looking for now is this angle. Now, there's different ways you can do that. You can do SOHCAHTOA, right sine. You know both sides. You can use cosine. That's also appropriate. What I'm going to go and use, I'm going to use tangent, because I know tangent is equal to opposite over adjacent. Tangent of theta is equal to opposite over adjacent. And I know that the opposite here, I know that this is 1, and I know this is 1. And so I'm just going to plug those in, and I'll see that this is 1 over 1. And that's a nice, easy number. Now, I got 1 because, remember, I know that this vector is 1 here, so I'll redraw the vector here. And I know this vector here is 1. They're all the same thing. Tangent theta is equal to 1, and what I'm looking for is, I'm looking for theta. Well, how do I find that angle? Rule number 1, if you want to get rid of something, always try the opposite. I want to get rid of that tan. It is a function, so you have to use something called an inverse function, which is inverse tangent. And you do that to both sides. And what you end up getting is the inverse tangent is of 1 will give you this theta. Now that is something that you will find inside your calculators.